Hello students, good morning students. Once look at the JEE mains paper, general organic chemistry questions. Here the first question is, which of the following species is most stable? The question. Carbocations are given. Carbocations are electron deficient molecules PNO2C6H4CH2. The structure benzene ring is connected. Here CH2 carbocation. At a para position, NO2 group is connected. This is benzyl carbocation, second option. Benzyl carbocation. Third one is at para position, CH chlorine is present. Fourth option at para position, CH3 is present. Carbocation is electron deficient molecule. Carbocation is electron deficient species. NO2 is the minus M group. It is withdraw electrons towards like this. OCH3 is the electron releasing group. It gives the electron density. This is plus M group. No mesomeric effect is present on the benzene ring here. A minus M effect as well as plus M effect is absent. Chlorine is electron releasing group, plus M as well as minus A effect is existing. Halogens, minus A effect is dominating compared to plus M effect for halogens. So to the carbocation, plus M groups, plus I groups are connected, carbocation stability increases. Minus M, minus I groups are connected, carbocation stability decreases. So among the four, option D is the correct option. Plus M group is connected, stability of the carbocation increases. Next question, observe that students, for the reaction, the reactions are given. Carbon chlorine, carbon chlorine, carbon chlorine, carbon chlorine. Bond cleavage. Between carbon and chlorine bond is present. That is cleavaging happening like this. The bonding electrons moving towards the chlorine. On the carbon, positive charge is generating, chlorine leaving as a Cl minus. So among the four cleavages, which cleavage gives the stable carbocation? Stable carbocation. Bond dissociation energy less, which is forms the stable carbocation. That bond dissociation energy is the less value. Unstable carbocation, bond dissociation energy more required. Unstable carbocation. Among the four, this is secondary carbocation. First one is secondary carbocation. This is allyl carbocation. Allyl connectivity is existing like this. That is allyl carbocation. This is benzyl carbocation. This is phenyl carbocation. Phenyl. So among the four, benzyl carbocation is more stable. We know that already based on the resonance. Benzyl carbocation has more number of resonating structures. So bond dissociation energy here less. Bond dissociation energy. After the benzyl carbocation, allyl carbocation is stable. Bond dissociation energy here less. So option for B, option B, why option B? Phenyl carbocation is the least stable, so bond dissociation energy more is required here. Here observe students, next question. Which of the following most stable carbocation? To that carbocations, what is connected here? CH3, 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 C2H5. CH3 here the para position, this is meta position, this is ortho position, this is C2H5 para position. You know that already hyperconjugation. Hyperconjugation. What is a hyperconjugation meaning? Hyperconjugation definition. sp2 carbon. This is sp2 carbon connected with sp3 carbon. That sp3 carbon having at least one hydrogen. This is alpha carbon. Alpha carbon connected hydrogen is alpha hydrogen. sp2 carbon. Next carbon is sp3. sp3 carbon at least one hydrogen is having, that is alpha carbon. Alpha carbon hydrogen is Alpha carbon hydrogen is alpha hydrogen. So the bonding electron shifting like this. The sigma bonding electrons, carbon hydrogen sigma bonding electrons moving towards like this. Sigma bonding electrons. This is hyperconjugation. Here this is sp2 carbon. Benzene carbon is sp2 carbon. The connected carbon is sp3 carbon. 3 hydrogens available. 3 hyperconjugation structures. So number of hyperconjugation structures increases, stability increases. Number of hyperconjugation structures increases, stability increases. Metaposition hyperconjugation is not existing. Conjugation is nothing but resonance. Resonance is possible para-position or the position not at metaposition. So here only inductive effect is existing. Next here, hyperconjugation is existing as well as inductive effect also is existing. Here ethyl group is present at para position. Ethyl connectivity to the benzene CH2 single bond CH3. This is sp2 carbon. This is sp3 carbon. sp3 carbon having how many hydrogens? 2 hydrogens. So hyperconjugations, how many are possible? 2 hyperconjugations are possible. Number of hyperconjugation structures increases, stability increases. Option A and C, here hyperconjugation is existing but inductive effect is absent. Here hyperconjugation existing as well as inductive effect is present. So that's why it is a more stable carbocation. Here the next question, student. Which of the following cation is most stable cation? This is already you know that the name tropylium cation. Tropylium cation is the aromatic compound. Aromatic compounds are highly stable carbocations. So option is A. Remaining are benzyl carbocation, benzyl carbocation, benzyl carbocation, 2 benzene rings connected with carbocation, 1 benzene ring connected, 3 benzene rings are connected, but that carbocation is outside the aromatic. This carbocation is present inside the aromatic. So it is the most stable carbocation. Next question, which is the most stable carbocation? Here deuterium is connected here to this carbocation, deuterium methyl groups, carbocation to 3 methyl groups are connected. Carbocation basically you know that electron deficient molecule to that electron deficient species. For suppose here the methyl groups are connected like this. Methyl groups nature, electron pushing groups, that is plus I effect. It push the electron density like this, pushing electron density like this. So carbocation needed electron density. So due to pushing groups, electron density moving towards the carbocation, stability increases. This is tertiary carbocation. This is primary carbocation. This is methyl carbocation. Based on the degree, tertiary carbocation is more stable. After that 2 degree, after that 1 degree. But here first option and last option, to that carbocation deuterium methyl groups are connected. Carbon hydrogen bond and carbon deuterium bond. Carbon deuterium bond strength is more compared to carbon hydrogen bond. Bond strength is more, pushing nature is less simply. So that's why it is the least pushing group compared to CD3. So option is D. Next question, students. 2 structures are given. Is more stable than 2. One is more stable than 2. Reason. This carbene ion actually it is. So carbene ion is electron rich. If it is electron is coming from the benzene ring, again electron density on the carbon increases. On the particular atom, negative charge again and again increases, stability decreases basically. Here NO2 group is connected. NO2 group nature is minus M effect as well as minus I effect. But at meta position, minus I effect is only existing. So minus M, minus I groups are connected. That means increases on the benzene ring. Carbene ion stability increases simply. Plus M and plus I groups are connected. Carbene ion stability decreases. Remember, this is the hint. What are plus M groups, what are minus M groups? In the previous video I already explained you. On which group at central atom double bond or triple bond is connected, that bond is connected to the more electronegative element, those are simply called as minus M groups. NO2 is minus M group, cyanide is minus M group, aldehyde is minus M group, ketone is minus M group, carboxylic acid is the minus M group, because of at central atom double bond is connected, that bond is connected to the more electronegative element, automatically withdraw electrons like this. Withdraw electrons like this means negative charge here decreases due to resonance. So option is B. Next question, which of the following is most stable carbocation? Which of the following? CH3 minus primary carbon ion, tertiary carbon ion. This is fluorines are connected. Here the chlorines are connected. Just only I told you. On the carbon, negative charge is decreases, stability increases. Here the fourth option, the carbon is connected to the chlorine. Chlorine has electron affinity value is more. Why electron affinity value is more? In the periodic table, most electron affinity value. Why it is stabilizes the carbon ion? Vacant d orbitals are available if you are observing the electronic configuration of the chlorine. 1s2, 2s2, 2p6, 3s2, 3p5. This is the chlorine electronic configuration. Atomic number is 17. Here this is the third shell. 3d orbital, vacant orbital is available. Due to presence of vacant orbital, the negative charge is delocalized into the vacant d orbital. So negative charge is delocalized means stabilized. But that kind of arrangement is not possible in the case of fluorine. Fluorine doesn't have any vacant orbitals. It is repulsions are existing with lone pair of electrons. Unstable. Pushing groups. Plus I effect. This is plus I effect. Due to plus I effect, carbon ion stability decreases. Next question. Unshared pair of electrons is contained by carbon ion having the negative charge. Unshared pair of electrons. Singlet carbene. Singlet carbene having the pair of electrons like this. Triplet carbene existing with linear arrangement in the two different orbitals. Electrons are existing with singly occupied. This is triplet carbene. Linear arrangement. sp hybridization. This is singlet carbene. Trigonal planar arrangement. sp2 hybridization. Both A and B. Here the next question observed here, students. Arrange the following carbene ions. Given these carbene ions in decreasing order of stability. Just only I explained previous examples. Carbene ion, if the electron density is coming, this is plus I effect as well as hyperconjugative group. This is plus M effect. This is minus M effect. This is minus M effect. Minus M groups, minus I groups are connected. Carbene ion stability increases. Plus M groups, plus I groups are connected. Carbene ion stability decreases. So least stable carbene ion is second option because of it is highly plus M group. Third option and fourth option both are increases stability, which is most stable carbocation. Minus M group, NO2 is the powerful minus M group compared to cyanide. So fourth option is the most stable carbene ion. 4, 3, 1, 2. Option A. Next question. Decreasing minus I effect order of given groups. So NO2 is the powerful minus I group. After that CN, then fluorine, then NaH2. So option is the D. So minus I effect order.
Okay, students. Bye, students.